if the radius of the circle is 1 unit. So all the circles they have the same radius is 1 unit. So let me take here one. Let me write a segment. Let me draw the segment from A to H. So here is the radius. So the radius we already know is 1. So this radius. And now we want to analyze just this triangle here inside. We want to know, for example, this is distance. How much is this distance? But because this is a radius is 1, and if we are looking, for example, and if we are going to make another radius from here to here is going to be 1. So just let me make another radius. So this radius here is 1, and because this is a right triangle, we see here is a 90 degree. So we can use here the Pythagorean theorem, and if we are using Pythagorean theorem, both sides are 1. So this side here is 1, and this is a hypotenuse. So the segment with a red color, HM, is hypotenuse. So HM is going to be equal with 1 square according to the Pythagorean theorem plus 1 square. 1 square plus 1 square is 2. So HM, the segment HM, is equal with square root of 2. So this here is the square root of 2. But if we are looking just to triangle, to this point here, for example, if we are looking triangle H from this point here and HA, so we already know this distance from here to here is the half. So let me write this with another letter. Let me write a L. So let me write a L here. And if we are looking at AL, this distance AL here and the HL are the same distances because this is a 45 degree, because this is 90 degree, but this segment here bisects the 90 degree angle, which means the both angles are equal bisects in two equal sides. And because here is 45 degrees, same thing happened with this here, with this angle. And this is isosceles triangle, what means that both of them are the same length. But because the length is HM is the square root of 2, HL is the square root of 2, so HL, so let me write here, HL is equal with square root of 2 divided by 2. So that's what is this is just this side here, square root of 2 divided by 2. But now if we are looking at distance from L to K, so LK, so let's say LK is equal with X. We don't know what is this here, so this is a X, LK here. So let me write a different color, maybe it's better if I write a different color. X is a X, so LK. How we can find the LK? LK we already know is radius 1 minus we are taking this distance LA. So X is going to be equal with radius, let's write radius R minus AL or HL, because both of them are equal. So let me write HL. Even if I write AL, it's not making any difference because both of them are the same. And now X is going to be equal, because radius is 1 minus, but HL, so this distance here is the same as HL is the square root of 2 divided by 2. So we already found X. X is equal with 1 minus square root of 2 divided by 2. But now we want to find, because the point here is to calculate the blue area of this square. And now we need to find this distance up to here, from K to the intersection of all these diagonals of the small square. But let me write here with one point here. So let me write this is O. And KO, I want to find this KO, what is going to be equal. But if we are looking here, so just let me take another segment. If we are drawing one segment from this position to this position here, so this segment is the same with this segment here. So this here we can make another square. So just let me draw here another. So we already see this is a square, and this distance from L to O is the same as AL. So the same distance, and we already know this distance is the square root of 2 divided by 2. And LO is the square root of 2 divided by 2. But I want here to find this the KL. So KL. Let's say KL, let it denote with a Y. So is equal with a Y. And now if I want to find the Y here, already we know LO is equal with AL or HL, which means Y is going to be equal with whole this distance here, LO minus X. We are subtracting X from here, minus X. But we already know LO is the square root of 2 divided by 2. But what do we know about the X? X we already have here. X is 1 minus square root of 2 divided by 2. Minus 1 minus the square root of 2 divided by 2. If we are distributing a minus inside, Y is going to be square root of 2 divided by 2 minus 1. And negative times negative is positive, square root of 2 divided by 2. Here I have square root of 2 divided by 2, plus square root of 2 divided by 2 is the square root of 2. So Y is going to be equal to the square root of 2 minus 1. So we already found Y. So we found the Y. But we already know this KO is equal with the OL and the OI and OJ. We already know that. But now, because this is equal, now I want to find the KJ. How we can find the KJ? So let me move a little bit, make space at the right. So KJ here, KJ is, and we see here a smaller triangle, right triangle we see inside, and the KJ is a hypotenuse. And a KJ is equal with, we are using the Pythagorean theorem because this is a 90-degree right angle, is KO plus OJ. So KO square plus KJ plus OJ, I'm sorry, OJ square. And because all of them here are the same, KO and OJ are the same, and they are equal with the Y. And Y is the square root of 2 minus 1. So KJ is equal with, so square root of 2 minus 1 square plus the square root of 2 minus 1 square. So everything is under square root. And now we are looking here. So let me work here. Because both of them are the same, so KJ we can write is equal with 2 times square root of 2 minus 1 square. And now the square can simplify with the index here, and it gets outside of the root, and the KJ is going to be equal with the square root of 2 minus 1, but this 2 stands inside the square root times square root of 2, but everything is here. Now if we are multiplying, square root of 2 times square root of 2 is 2, so KJ is equal with the 2. And here is a negative times positive is a negative, and square root of 2 times 1 is a square root of 2. So this is a KJ. And now we are almost to finish. We want to find this area. We can find the KJ times JL, but KJ and JL are the same. In the square, we can write the blue area. So let me write with a different color. So the area of the blue square is equal with the KJ square. KJ square. So this is equal, and the area of the blue square is equal. So we already have, this is a 2 minus square root of 2. So this is equal with a 2 minus square root of 2, and everything is square. If we are distributing this, or if we are multiplying 2 minus square root of 2, or if we are using this binomial formula, we can find the blue area is equal. So the first one is in square. 2 square is 4 minus 2 times the first one, 2 times square root of 2, plus the second one is going to be square, and square root of 2 square is just 2. If we are adding everything here, in the blue area, the area of the blue square is going to be 4 plus 2 is a 6, and here 2 times 2 is a 4 square root of 2. If we are calculating in a calculator, it's going to be approximately 0.3 units square, or 6 minus 4 square root of 2 units square. So this is the answer for the blue square. So area of the blue square is equal to 6 minus 4 square root of 2 unit square, or approximately with a 0.3 unit square.